Now exercise 1.3 and second number sum. 3 plus 2 root 5 is irrational. Prove that. Not just like first one is bigger. Now here we accept that root 2, root 3 and root 5 are irrational numbers. So let again we suppose the wrong one. 3 plus 2 root 5 is rational number. If it is a rational number, then 3 plus 2 root 5 can be written in the form of a by b. Remember, b is not equal to 0, and remember a and b belongs to integer z. This is the sign of belongs to. Belongs to means a and b are integers in short. Now see, 3 plus 2 root 5, take plus 3 this side. Okay, so we have 2 root 5 equal to a upon b minus 3. 2 root 5 equals to, take b LCM, a keep it as it is, multiply this term by b, 3b. Now 2 is in multiplication, move down. So root 5 equals to a minus 3b, and 2 moves down upon 2b. Now see, a and b are integers. So this fraction is called rational number. Therefore, a minus 3b upon 2b is a rational number. But this is equal to root 5, so we prove that root 5 is a rational number. But before this sum, in number 1 sum, we prove that root 5 is an irrational number. But it is not true that root 5 is a rational number. Therefore, root 5 is an irrational number, and therefore 3 plus 2 root 5 is an irrational number. Our supposition is wrong, right? And therefore we write 3 plus 2 root 5 is a rational number. Okay? Naturally, another simple method is also there. 3 is rational number plus 2 root 5 is irrational number, because root 5 is irrational. Remember, combination of rational number and irrational number is always irrational number. Combination means plus or minus. Okay? Then it is an irrational number. So in this way we can prove. Now question number 3, prove the following are irrational number, just like the same as 2. First question is 1 upon root 2. Prove that 1 upon root 2 is an irrational number. So we suppose again the same way 1 upon root 2 is a rational number. And then we try to prove that our supposition is wrong. If it is a rational number, then it can be written in the form of a by b. Once again we said b is not equal to 0 and a and b are integers. That means cross multiplication gives you b ones are b equal to root 2a. A is in multiplication, take this side, so b upon a equal to root 2. But root 2 is irrational. Here we suppose that root 2 equal to b upon a. B upon a is also irrational. That b upon a is rational number. Because we take a upon b is rational, so b upon a is also rational number. Therefore we take root 2 is rational number, but you know the theorem, root 2 is irrational number, but it is not true. Therefore 1 upon root 2 is an irrational number. Is it okay? Now question number 2. 7 root 5. 7 root 5. Again, let 7 root 5 is a rational number. Therefore, it can be written like a by b. Again, b is not equal to 0 and a, b are integers. Therefore, root 5 equals to what? A upon 7b. A upon 7b is a fraction. You can write a upon 7b is a rational number. A upon 7b is a rational number. It means root 5 is also a rational number, but it is not true because root 5 is a irrational number. It is not true. Therefore, we said that a upon 7b is also wrong. Our supposition is also wrong. Therefore, 7 root 5 is an irrational number. Third number, 6 plus root 2. Again, suppose 6 plus root 2 is a rational number. Therefore, it can be written in the form of fraction a upon b, where b is not equal to 0 and a and b are integers. Therefore, root 2 equal to a upon b minus 6. Take b LCM, a as it is, b multiplied here 6b. It means a minus 6b upon b is a rational number. A minus 6b upon b means root 2 is a rational number. Root 2 is a rational number, but you know that we have a theorem that root 2 is an irrational number, so it is not true. If it is not true, you can write that 6 plus root 2 is an irrational number. This is your exercise 1.3. See the video again and again and try to repeat these sums. Okay? Note down these sums in your notebook. We will start exercise 1.4 in next lecture. That's it.